Mr. Lucier's Chemistry. Hey, good morning everybody. Welcome back to chemistry. Today we're going to be talking about ionic naming, ionic compounds. But before I can talk about ionic compounds, we got to go over basic bonding here. Now, when you look at the periodic table, okay, we talked about the valence electrons here. How group 1 has 1 valence electron, group 2 has 2 valence electrons, and so on with group 3 through 18, right? And then we talked about, okay, these valence electrons have to do with bonding. Is it easier to try to gain to get 8, or is it easier to lose everything to go to 0? So that's what we're talking about today, is basic bonding. But the part we're going to talk about first is oxidation numbers. Okay? What is an oxidation number? Well, it tells you what the element's going to do with their valence electrons. Okay? So again, what is an oxidation number? It tells you what the element's going to do with their valence electrons. So let me get my pen here. So if you look at group 1, we know it's easier to give away that 1 electron than to try to gain 7 more. So I know he's going to give away that 1 valence electron. So if you remember from last videos, that it's actually when you lose an electron, right? When you lose an electron, you actually take on a positive charge, okay? And you form a cation. So this is super important to remember. When you lose an electron, you take on a positive charge and you form a cation. When you gain an electron, you take on a negative charge and you form anions. Okay? So, right here, group 1 wants to give away, so we're going to get a +1 charge here, oxidation number. Okay? So this whole group has a +1 oxidation. The oxidation numbers are going to become super important. Group 2, it's easier to give up 2 than to try to gain 6. So they're going to take a +2. Now, these middle guys right here, I'm just going to make this super generalized rule. We're going to say they are +2 unless told different. Okay? And most of the time, they will just be given to you. Except for silver. Silver is always +1. Not always, but most of the time +1. But this is a super general rule. It's not concrete, okay? Because these guys have multiple oxidation states that we're not going to go into right now. Now, then we get to group 13. They have 3 valence electrons. Again, it's still easier to give away 3 than to try to gain 5 more. So they take a +3 charge. And carbon and these guys, they're in the middle. Okay, so they're going to go plus or minus 4 because they can either give up or take since they're in the middle. They're kind of like hydrogen. Now, these guys has 5 valence electrons. Now we've crossed the river here, right? 5 valence electrons, it's actually easier to take on 3 more than to try to lose 5. So they get a -3, -2, -1. And the noble gases are doing nothing. They're not giving or taking because they have a full last shell, so they're all 0. They're not going to do any kind of reacting. So these oxidation numbers are super important when it comes to bonding. Let me give you an example. First of all, let's say we have Be, right? Be. His oxidation number is a +2. Let me pull this up. Actually, let me slide it up. His oxidation number is a +2. So I'm going to give +2 to Be, right? Now, let's pick, I don't know, chlorine. Chlorine has a -1 oxidation number. So I'm going to go Cl -1. Okay? Now, if Be wants to get together with Cl, just like dating, when you like somebody, what's the first thing you do? You give them your phone number, right? And you can look at oxidation numbers like phone numbers. So when Be wants to get together with chlorine and chlorine wants to get together with Be, they're going to swap numbers, okay? So that means 2 is going to go to chlorine and this 1 is going to go to Be, okay? So when these two guys hook up, you're going to end up with a Be with a 1, except in chemistry, we do not write 1s because I can see there's one Be, and chlorine got that too. So we end up with BeCl2. Bonding is that easy, guys. All you do is put the two elements together and switch their oxidation numbers, okay? We put the two elements together and switch their oxidation numbers. So this is basic ionic bonding. So, one quick caveat here. When you're bonding the metal, ionic bonding, the metal always goes first and the non-metal goes second. Okay? So, let's just say non-metal. So the metal goes first, non-metal goes second, and another, remember I said we do not write 1s. He got a 1 from chlorine, but we don't write 1s. And all we did was switch oxidation numbers that you find on the top of your periodic table. So now you can bond together any element. So what is this telling me here? Well, this is telling me that Be is connected to 2 chlorines. Okay? So we're going to end up with some compound kind of looking like this. A Be that's connected to 2 chlorines. Right? A Be connected to 2 chlorines. So this is basic bonding, okay? The reason why I'm teaching you basic bonding is because we're going to start talking about naming ionic compounds, okay? And to do naming ionic compounds, you've got to know basic bonding. So just remember, you assign oxidation numbers and you swap and drop. You swap the numbers and drop them down and push the two elements together, and that's your compound. Okay? Now, I kind of briefly skirted over what an ionic compound is. An ionic compound is when you have a metal that is bonded to a nonmetal. A metal that is bonded to a nonmetal. Okay? Now, let's look at your periodic table here. What's our metals and what's our nonmetals? Remember this when we talked about periodic families? This zigzag line here separates your metals from your nonmetals. Okay? This side is your nonmetals. This whole side, this right side is your nonmetals. This whole side is your metals. Okay? So I should write right side. This is your left side of that zigzag line. Zigzag. Right? Right side, left side of that zigzag line. So when we have an ionic compound, what we're saying is we have a compound we have some guy from this guy bonding and hooking up with some guy from this side. Okay? That's what an ionic compound is. Super simple. When you have a metal bonded to a nonmetal. Okay? They call them ionics because they're actually forming ions. But we'll talk about that later when we get to actual ionic Lewis dot bonding, so you can see that. Right now I'm just going to give you general naming rules. Okay? We're going to learn how to name any ionic compound. Okay? So there's rules here. So, rule number 1, right? First we're going to start with the metal, and then we're going to talk about the nonmetal. Okay? Metals first. Whenever you run into any compound. Oh, by the way, when you see a compound, you look at it like this. It's the metal and then everything else, right? You look at the first guy and then it comes down to everything else. You'll see that again later. It's the metal and then everything else. Because let's talk about the metal first. Okay? Naming the metal part of ionic naming. Okay? Now with the metal, it's easy. If it's a single metal or it's a regular metal, regular metals always keep their name. So if I was saying let's say I was looking at example FeCl3, 2. Yeah, FeCl3 is good. Okay? So if I was naming this compound right here, this will just be iron, because the metal always keeps its name, right? Because you could break this into two parts. The metal and then everything else. Okay? So the metal keeps its name, really simple. But you got to watch out. There's also transition metals. Is it a transition metal? You got to check. Where are your transition metals? Your transition metals are these guys right here on the periodic table. Went too far. If it's anywhere in this box, if you remember your naming, your families, okay? Those are your transition metals, okay? So when you're naming, you got to check. Is it a regular metal, your alkali and alkali earths, or is it a transition metal, one of these guys right here, okay? So is iron one of those guys? Yes, he is. Iron is, where'd it go? I just saw it. He's always in the middle, right here. Here's iron right there, right? So iron is a transition metal, okay? Now there's a special rule if your metal is a transition metal. If it's a transition metal, it also keeps its name, but you got to include the oxidation number in Roman numerals. Okay? You got to include the oxidation number in Roman numerals. So remember, this is 1, 2, 3, 4. What's 4? That's 1 before 5, right? 5 is V. 6 is 1 after 5. 7, 2 after 5. 8 is 3 after 5. So you shouldn't get any higher than that. Okay? So this is 1, 2, 3, 4, 5, 6, 7, 8. So let's look at this right here. What was iron's oxidation number, right? Remember when these two guys hooked up, they switched oxidation numbers, right? When those two guys hooked up, here's the example. When they hooked up, they switched oxidation numbers. So what was BE's oxidation number? Well, if I look right here, I knew BE's oxidation was here, right? It was 2. But where did this 2 come from? It's BE's oxidation number. So whenever you want to look up a metal's oxidation number, go look at that number at the end. So look right here. What is iron's oxidation number? Well, what did iron give the chlorine when they hooked up? He gave them the 3. So you're going to undo the swap and drop. That's why I taught that swap and drop to you. So you can see that this number actually came from the iron. So if I was to start this guy's name off, his name would be iron, because metals keep their name. But since iron is a transition metal, I got to include his oxidation number. So he gave that 3 to chlorine, so this is iron 3, right? Remember, you only do this if it's a transition metal, one of these guys right here in the middle. If it's one of these guys over here, you don't have to worry about the oxidation numbers, because we know there's 1 and 2, okay? Those never change, but these guys can have different oxidation numbers, so we have to specify what his oxidation number is, and that's not hard because it's always at the end, okay? Now, if you don't see no number here, that means his oxidation number is 1, right? Or there's other things where oxidation numbers cancel out, but I'll have to show you that in a little bit. All right, guys, we got ionic compounds part 2.